Hey everyone, in this video we will apply the seismic load onto the building model that we have created in the previous video. The problem is given as shown, which is same as in the previous video. Open the building model that we have saved. Now we are going to add the seismic load on our building as per IS 1893 codebook. So go to define menu and select load patterns option. Enter the load name as seismic. Change the load type to seismic. And in the option for auto lateral load, select the IS 1893 code. Then click on add new load. Then click on modify lateral load. Here we will set the properties of the seismic load added. We will consider the seismic waves to be acting on both x and y direction. So select both x and y direction option as shown. The values which I am using here are taken from IS 1893 code. Choose the program calculated option under time period, and the time period will be automatically calculated depending on the dimensions of the building. The properties of the seismic load have been set and the load has been defined. Click on OK. Now we will set the load combination by including the seismic load we have just defined. So go to the define menu and select load combinations that include dead, live and seismic load are already added, as we can see here. Now click on OK. Now the next step is to perform the structural analysis on our building model. As we are performing only the seismic analysis on the building model, there is no need to run the analysis for wind load case. So go to analyze menu and select load cases to run option. Select the wind load case option and click on run do not run case to change the wind load case properties. Now click on run now to perform the structural analysis on our building model. Wait for some time as the software runs analysis on building model. Once the analysis is done, the analysis results will be displayed as shown. We can place our cursor over the points on the slabs in the 3D view tab to see the displacement values. Now we will run the structural design on the building model. So go to the design menu, select concrete frame design option and then click on view or revise preference option. Make sure IS 456 code has been selected. Click on OK. Then again in the concrete frame design option, select start design check option. Here the design has been completed. Let's check whether all the members are passed or not. Click on design, then concrete frame design and then click on verify all members passed. As it is showing, all concrete frame passed the design check. Hence we have successfully designed. Now we will perform the seismic analysis on our building model based on response spectrum method. Since we have done analysis on the model, it is logged now. So unlock our model first. Now we will add the response spectrum function on the building model as per IS 1893 codebook. Before adding the response spectrum function on the building, ensure that we have added the seismic load. So now go to define menu, select load patterns. Now select and click on modify lateral option by selecting the seismic load. Make sure both X and Y directions are selected. Set the remaining properties like zone factor, site type, response reduction factor, importance factor based on our location as we did in earlier video. Now we will add the response spectrum function to our building model. Go to the define menu, choose function properties and click on response spectrum. A new window will appear. In that window, first select the IS 1893-2002 option. To create the response spectrum function. Type the name as response spectrum in the file inbox. Set the remaining properties based on our location as we did earlier. Click on OK. The properties of the seismic response spectrum functions are now set and the function is defined. Click on OK to exit the window. We will now set the load case by including the response spectrum function we have just defined. We need to enter the acceleration values. To define the load case for the response spectrum function. So check the units of acceleration parameter before proceeding as we did earlier. Here the units are mm per second square. Now go to define menu and select the load case option. Click on new case option. Here we will set the properties of the new load case. Name the load case as response spectrum function as shown. Select the load case type as response spectrum. Click on add in the load supply dialog box. A new load is added. Now select the response spectrum from the function drop down menu. Calculate the scale factor value from the given formula as shown. The value is 1633.5. We will now add another load to account for the seismic response spectrum in the y direction. So add another load. Select the load name as U2 and enter the same selected scale factor value as done earlier. Change the function to response spectrum. The seismic response spectrum function load case has been defined. Click on OK to exit. In the case of response spectrum function, we need not to select any building element to assign the load. After defining the response spectrum function, the next step is to perform the structural analysis on our building model. Now go to the Analyze menu and select Set Load Cases to run. As we are performing seismic analysis, there is no need to run the analysis for the dead and live load cases. So we are going to perform the analysis for seismic and response spectrum load cases only. Change the dead and livelihood cases action as do not run. Now click on run now option to perform the analysis on our building model. Wait for some time as the software runs analysis on the building model. Once the analysis is done, the analysis result will be displayed as shown. By default, the displacement values are shown on in the 3D tab. We can place our cursor over the points in the 3D view tab to see the displacement as shown. Now, we will run the structural design on our building model. So, go to the design menu, click on concrete frame design option, and then click on start design check. Wait for some time as the software runs design on building model. Once the design is completed, the software asks our permission to reiterate the analysis and design of the failure member. So click on yes to perform reiteration. Because we have defined the auto select option for beams and columns, the software automatically performs the analysis and design processes for new frame sections. The design has been complete. Let's check whether all the members are passed or not. Click on design option, then click on concrete frame design option and click on verify all members passed. As it is showing here, all concrete frames pass the design check. Hence, we have successfully carried out the design process. ETAP software also provides the complete project report of a building model. We can find the information of the building model which is properly mentioned in the project report. Double click on the summary report. The information like load patterns, section dimensions, analysis results, etc. All the building elements are mentioned. We have successfully completed the seismic analysis of our building model based on response spectrum method. Now, we will perform the seismic analysis on our building model based on time history method. Since we have done analysis on the model, it is logged now. So unlock the model first. Now, we will add the time history function on the building as per IS 1893 codebook as we did earlier. Before adding the time history function, ensure that we have added the seismic load. To check that, go to Define menu, select Load Patterns. Here, seismic load is added. Now select the seismic load and click on Modify Lateral Load. Now, we will consider the seismic waves to be acting on only on x direction. So select only the x direction option as shown. Set the remaining properties as it is as we have done earlier. Click on OK to exit the load pattern window. Now, we will add the time history function to our building model. In the Define menu, choose Function and select Time History. A new window will appear. In that window, first select From File option as shown. Now, we are going to import the time history data file of Bhuj earthquake occurred in the year 2001. First, add new function. Change the name as time history. Click on Browse option to import the time history data file as shown. Set the remaining properties in the window as we did earlier. Then click on OK. We will now set the load case by including the time history function we have just defined. Now go to Define menu and select the load case option. Since we are performing the time history analysis, there is no need for the response spectrum load case. So delete the response spectrum load case as shown. Select the load case type as time history. Click on Add in the load supply dialog box. But before, we have to change the load case type to time history. Yes. Then click on Add. Select the acceleration option from the load type drop down as shown. Select the function as example time history data. Calculate the scale factor value as we have done earlier and specify it here from this formula, and the value comes out to be 1633.5. Specify it here. The data file of the seismic time history has the ground acceleration value only in the x direction. So there is no need to add another load for the y direction. Set the remaining properties as we did earlier. Click on OK. The seismic time history function load case has been defined. In the case of time history function, we need not select any building element to assign the load. Now go to Analyze menu, select Load Cases to Run option. As we are performing seismic analysis, there is no need to run the analysis for the dead and live load cases. So we are going to perform the analysis for seismic and time history load cases. Change the dead and live load cases as do not run, as it is already been selected. So leave as it is. Click on Run Now option to perform the analysis on our building. Wait for some time as the software runs analysis on the building model. Once analysis is done, the analysis result will be displayed as shown. By default, the displacement values based on the seismic load case are shown in the 3D tab. We can place our cursor as shown in the 3D tab to see the displacement value as shown. Now we will run the structural design on a building model. Go to the design menu, select concrete frame design option and then click on start design check. Wait for some time as the software runs design on a building. The design has been complete. Let's check whether all the members are passed or not. Click on design menu, then click on concrete frame design and click on verify all members passed. As it is showing that all concrete frames passed the design check, hence our design part is complete. This completes the structural design of our building model. We have successfully completed the seismic analysis of our building model based on time history method. Thanks for watching.